Hello, and we're back. What are we doing today? What are polar coordinates? So another way of specifying location other than x and y, what we call rectilinear, like rectangular coordinates, because it's horizontal and vertical grid on the graph paper we're used to. Also known as the Cartesian plane, named after René Descartes, who came up with this idea of horizontal and vertical grids. Great French mathematician and philosopher, René Descartes, the Cartesian plane. All right, so let's take a look at what it means to graph in polar notation. What if I gave you a point in r theta notation instead of x and y? What does that mean? Well, it's hinting at vectors, because vectors have a magnitude and a direction. That's what r is, a magnitude, and that's what theta is, a direction. Now, let's see, what does polar graph paper look like? Well, we don't have an origin, we have a pole. We don't have an x-axis or a y-axis, we have a polar axis. And instead of a horizontal and vertical grid, we have concentric circles. Say 1 unit out, 2 units out, 3 units out, 4 units out, say. It looks like a radar on an air traffic controller screen, or a sonar in an old submarine World War II movie, okay? So what does it mean, 2 pi over 4? That means go from the pole, 2 units out, but rotate counterclockwise, like we usually measure angles from the positive x direction, then counterclockwise, pi over 4 radians, or 45 degrees. So say right around here. All right, let's say that's a point A, so let's label stuff. That's a point A, so we know which is which. How about point B? What would the 3, 0 mean? Well, 3, 0 would mean go out 3 from the pole, and don't rotate up or down at all, just stay there. So let's call that point B. All right, this is a quick summary of what we did in class today. How about, what if I said 4, 5 pi over 3? Where is that? Well, go out 4 units. We could go 5, 6 units, whatever you need. Polar paper would have more circles probably. So go out 4 units from the origin, and then go 5 pi over 3 radians measured counterclockwise. Well, you know what that is, right? Don't you know that's 300 degrees? Because pi is 180. Over 3 is 60 degrees, times 5 is 300 degrees. And if you superimpose your regular quadrant system here, that would be in the 4th quadrant, 60 degrees below the axis, right? So let's go 4 units out, 60 degrees from the axis, let's say that's here. And that's the point, that's the point C, yes. All right, now be careful, this is weird, but what if I have a negative 4, 5 pi over 3? That's what that means is, go from the point 4 pi over 3, the point C, and reflect it through the pole to the other side. That's the point D. Alrighty? Alright, how about this one? The point E is go out 4 units, but go negative 5 pi over 3. Well, if positive 5 pi over 3 meant rotate counterclockwise 300 degrees, now we're rotating clockwise 300 degrees. So go clockwise 300 degrees, and aren't you in the first quadrant, 60 degrees from the axis. So let's say that would be the point E is like up here. So then what does negative 4, negative 5 pi over 3 mean? Well, negative 4, negative 5 pi over 3 is the same thing as 4, negative 5 pi over 3 if we reflect the point E through the pole to the other side. And that's the point F. All right, so that's just giving you an idea of how to graph. If I gave you polar coordinates, how to graph those points in polar coordinates. And that's what polar graph paper looks like. And that's it. Alrighty. Now, the homework tonight was page 5. I thought I changed that. That's very strange. I thought it's 567. Where did that come from? Oh. Oof. All right. Don't worry about that. That's 567. I'll fix that later. It's page 567 multiple to 5 for tomorrow night. This is Monday. Sorry, let me put up Monday. Today's Monday. There you go. That's weird. What happened there? All right, I'm going to have to fix that later. So page 567 multiple to 10 tonight. And all you're doing there is graphing like this and converting. Now, what if I gave you a point like, say 6, pi over 6. And in other words, I gave you r theta format. And I want you to convert it to x and y format. Okay? All right, so what does that mean? Well, pretend that this is the sixth circle out, right, on a polar graph. And let's superimpose on that a rectangular grid. Here's your y-axis, here's your x-axis. Well, that's weird. Here we go. Like that. Okay. Now, where is 6 pi over 6? Well, that means go from the pole. Let's say that's here. Out 6 units. Let's say that's the circle. And rotate counterclockwise pi over 6 radians, or 30 degrees. So let's say it's like around here. And what's nice about rectilinear graphs, we're putting horizontal and vertical things here, is you can always draw a right triangle touching the x-axis to help you out. All right, so this is the point x and y. What we know is that r is 6 and theta is pi over 6. We got to figure out x, which is this horizontal leg, and we got to figure out y, which is this vertical leg. And so we figured out in class that this is just SOHCAHTOA. Is there a relationship between x, theta, and 6? Yeah, the cosine of pi over 6 is x over 6, so x is 6 times the cosine of pi over 6. And so, in other words, this is really a convergent formula. If you're given r and theta, r cosine theta will give you x. But let's reduce that. The cosine of pi over 6 radians, remember, or 30 degrees, is rad 3 over 2. And the 2 and the 6 reduce, so 3 rad 3 is x. So that's my answer. What's x and y? Well, I got x. And remember, rad 3 is about 1.7 times 3 is about 5.1, 5.2, somewhere in there. So that's how far out in x you go. How about y? Well, same thing. Is there a relationship between y, theta, and r? Well, let's see. It would be SOHCAHTOA sine. So sine of theta, sine of pi over 6, is the opposite over the hypotenuse. And multiply both sides by 6 to get y alone. And don't forget, we did 3 chapters of trig so that you would know that the sine of pi over 6 radians, or 30 degrees, is 1/2. So 6 times 1/2 is 3. So y is 3. There you go. Alrighty. Let's try that again. What if I gave you -4 comma negative pi over 4? Now remember, 4 pi over 4 would be in the first quadrant. 4 negative pi over 4 would be in the fourth quadrant. Then -4 negative pi over 4 would be reflecting that point through the pole to the second quadrant. So it would look like this. So draw your right triangle. This is x, this is y, this is r, and this is theta. Now it's not really theta. We make the distinction between alpha, an angle less than 90 inside the right triangle, and theta, the angle that we're really looking for. Okay, so this is theta. It's sometimes bigger than 90, depending on what quadrant you're in. Be careful. So when I draw the triangle, though, I pretend I'm in the first quadrant. Nothing's negative. Okay, so let's do it again. What we said the last time. The cosine of pi over 4 radians is x over 4. So 4 times the cosine of pi over 4 is x, but cosine of pi over 4 radians or 45 degrees is rad 2 over 2. So we get 2 rad 2 is x. And again, rad 2 is about 1.424, so twice that is 2.848 roughly. So if this is r and theta, we've converted to x and y. We got the x part 2 rad 2. What's the y part? Well, now be careful though. You're in the second quadrant, so it's not 2 rad 2. It's -2 rad 2 because you're in the second quadrant. So you have to interpret that after you're done with the SOHCAHTOA stuff, which is always first quadrant stuff. All right, what about y? Well, the sine of the sine of the angle, which is pi over 4, is y over the opposite over the hypotenuse, y over 4. So cross multiply if you must, or multiply by 4. And you get the same thing, don't you? Happens to be the same. So, but it's positive because we're in the second quadrant. Okay? So worry about the quadrants when you're done. So again, here's your conversion formula. If you're given r and theta, r cosine theta is x. If you're given r and theta, r sine theta is y. And theta and alpha are the same in the first quadrant. Theta and alpha are not the same in the other quadrants. We'll talk a little bit more about that. All right, how about we go backwards? Can you convert from r theta to x and y? Let's see. What if I gave you, oh, sorry, I did that already. From x and y to r theta. What if I gave you 2, negative 2 is x and y. And I want to convert that to r and theta. Okay, so fill in the blanks. Alrighty. So what quadrant are we in now? Now this is Cartesian, so quadrant 4 clearly. So we don't really need to draw the circle, but here's your y-axis, here's your x-axis, and if you're at 2, negative 2, that's going to be 2 this way, 2 that way. Your point is here. Now how are you going to draw your triangle? Straight to the perpendicular to the x-axis, and then straight to the origin of the pole, if you like. And so let's just focus on this triangle. Alrighty? It's 2 units this way, 2 units this way. It's a right triangle. I need to figure out alpha. I need to figure out r. All right, well, that's not too tough. Is there a relationship between x, y, and theta, or 2, 2, and alpha? Isn't the tangent of alpha the opposite over the adjacent? Now, how do you get rid of tan? The inverse tan, or the second tan in your calculator, of 1 in this case, is pi over 4 radians, or 45 degrees, isn't it? Because remember, tangent is sine over cosine. And so if we have sine of pi over 4 radians, it's rad 2 over 2 over cosine of pi over 4 radians, or 45 degrees, is also rad 2 over 2, so you get 1. All right, so there's your alpha. Now be careful, that's alpha. What's theta? Well, if you think of it in degrees, we're going 45 degrees into the 4th quadrant. So that's really like a negative 45. But the positive angle, counterclockwise, would be 360 minus 45 is 315. So you could write 315 degrees here, or you could write 7 pi over 4, isn't it? Because pi over 4 is 45 degrees, right? So 1 45, 2 45, 3 45 is 4, that's pi, or 180 degrees, pi radians. And then 5 pi over 4, 6 pi over 4, 7 pi over 4 is where we're at. And 8 pi over 4 is 2 pi. Yeah, that's right. There you go. Now what's r? Well, is there a relationship between x, y, and r, or 2, 2, and r? Yeah. It's 2 squared plus 2 squared is r squared. So 4 plus 4 is r squared. So r is rad 8, or rad 4, rad 2 is 2, rad 2. And we get 2 rad 2 again. It's my favorite number, apparently. And there you go. Alrighty. And I think that will give you enough to get you started on the homework. So let's let you get started with the homework. Okay, that's good. That's a short review of what we did today. And thanks for coming, YouTube. Bye-bye.